Hello students, today's topic is downstream processing in large-scale cultures. Bioprocess involves two major stages, upstreaming process and downstreaming process. This is followed by quality control. Upstream process involves scale-up processes like production of biomass and metabolites. The downstream process involves the extraction, separation, and purification of the end product. The figure below shows a flowchart of the upstream and downstream process. The bioprocess starts with the inoculating or seedling small-scale cultures into bioreactors for large-scale production of the product, that is, the upstream process. Based on whether the product is intracellular or extracellular, the separation and purification strategies are decided in the downstream process. If the desired product is extracellular, the cells are removed by solid-liquid separation. If the product is intracellular, the cells are disrupted to release the product and then solid-liquid separation is done by means of centrifugation, sedimentation or filtration based on the cell properties. This is followed by concentration and extraction of the product. This will be determined by the physicochemical properties of the product, example, size, charge, hydrophobicity, to name some. Next, formulation of the purified product is done and followed by quality evaluation. The figure here shows the steps for production of biopharmaceuticals, both upstreaming and downstreaming processes. The various approaches utilized for downstreaming processes are: first, solid-liquid separation, which is done by means of flocculation, centrifugation, or filtration. If the end product is an intracellular product, then cell disruption is done by means of homogenizers or by use of hydrolytic enzymes or by chemical methods. Clarification of the product is done by means of centrifugation and filtration. This is then followed by concentration of the end product. It is based on the properties of the product. It could be by means of precipitation, different chromatographic techniques, partitioning, distillation, or ultrafiltration. After the product is concentrated and highly purified, finishing and packaging of the end product is done by means of crystallization, filtration, and drying. There is no universal or ideal protocol applicable for all downstream processes. A combination of 2-3 purification techniques are employed to get an active pharmaceutical ingredient or API. The downstream step stands with cell wall harvesting and cell disruption, followed by clarification to remove insoluble and particulate matter. Separation of cells in large scale is usually done by centrifugation. For intracellular products, the cell fraction is retained, while for extracellular products, the culture media is reserved. Other methods used are flotation, coagulation, flocculation, and filtration. Flotation. It is a solid-liquid separation technique based on density of the particle. It constitutes gravity separation process. The particles have either less density than the liquid or made to become by introducing gas into the liquid to form bubble. The bubbles attach to the particulate matter, and because of the buoyancy force, the particle rises up and forms a scum on the surface. This is then removed by skimming mechanism. It could be by means of dispersed air flotation method or dissolved air flotation method. Dissolved air flotation method. In this method, a liquid stream saturated with pressurized air is passed onto the DAG unit and mixed with incoming feed, as shown in the figure. The feed could be cells and media. As the pressure returns to the normal atmospheric pressure, the dissolved air is released into the media as small bubbles. These bubbles coalesce with the particles, increase the buoyancy, and rise up to the surface. They can then be removed by a skimmer. Dispersed air flotation method. In this method, the gas is released into the media via chemical or biochemical reactions. Example, in electrofusion as shown in the figure. In this, the bubbles are created by hydrolysis of water by passing current through a inert electrode. In some cases, chemical additives like xanthines, fatty acids are added to promote flotation. These chemicals increase the particle adhesion on bubble surface. In some cases, foaming agents are also added. They act as surfactants that favor formation of gas bubble and its stability. Coagulation. Coagulation is a process of destabilizing the dispersed colloids by addition of coagulants to make small flocks which can then be removed by settling or flotation methods depending upon the density of the molecule or particulate. Coagulants are generally divalents or trivalents of metallic salts or polymers that have low solubility in the pH range used. Based on the principle used, it is grouped into chemical coagulants and biocoagulation. In chemical coagulation method, chemicals like sulfate salts of ammonium or ferrous or ferric sulfates, aluminium chloride, polyamines are added and mixed vigorously for a short period of time. This leads to change in surface charge of the molecules. In most cases, coagulants neutralize the negative charge on the colloids and bring them closer. The biocoagulation method is generally done for proteins. The proteins are denatured by increasing the temperature or by adding coagulants. This leads to aggregation of proteins. In this method, colloidal and small particulate aggregate to form larger size particles as shown in the figure, which can be removed by sedimentation, flotation, or filtration methods. Flocculation. It is similar to chemical coagulation. It is agglomeration of microflocs generated by coagulation or particles to form larger flocks which can sediment. The flocculating agents like polyamines, calcium chloride, polyethyleneamine are absorbed to particles usually by electrostatic attraction. They neutralize the negative charge on the colloids. The figure shows the process of flocculant in CHO cells to recover glycoproteins by using polycationic flocculating agents like polyethyleneamine. The figure here shows different mechanisms of coagulation and flocculation brought about by different coagulants and flocculants. In charge neutralization method, the coagulant or flocculant is positively charged and is absorbed on the surface of the negatively charged colloids, neutralizing the charge on them and bringing about aggregation. Sweep coagulation is done for water treatment in water treatment plants. Here, large concentrations of metal ion salts are used, which bring about precipitation of or coagulation of metallic salts. Bridging occurs when a polymer chain absorbs more than one particulate, linking particles together. In patch flocculation method, a polymer or a coagulant absorbs onto opposing charged particle surface to give a non-uniform distribution of surface charge. Electrostatic force between oppositively charged particles promote aggregation. The figure here shows a representation of solid-liquid separation by means of using coagulants and flocculants, leading to sedimentation of larger particle molecules. Centrifugation. In large-scale pharmaceutical units, continuous separation is done to separate solid-liquid phase. It works on sedimentation principle. The centripetal acceleration makes denser particles to get displaced away from the axis and lighter ones to move towards the center. Different designs of centrifuge are used. Example, tubular bowl centrifuge, disc centrifuge, and multicellular centrifuge. The figure on the extreme right shows a typical large-scale centrifuge. The feedstock is split into two or more portions after centrifugation. The product stream is captured while the waste stream is discarded. The figure here represents a layout of a harvest process where the cells are harvested by means of disc centrifuge. Filtration. It is the process of removal of cell debris or particles. Certain feedbacks which have large amount of high density debris, clarification with centrifugation is necessary prior to filtration. Different types of filtration units are present. First, depth filters. They are composed of filamentous matrix and the particles get entrapped into the matrix, as shown in the figure below. Absolute filters. They have definite or specific pore size than that of the particles to be removed. It is generally done to remove bacteria. Rotatory drum vacuum filters. It consists of rotating drum that is immersed in the media. As the drum moves or rotates, it picks up the mass which forms a cake. Membrane filters. Surface filters, filtration on the basis of pore size of the membrane. Here, the particles are retained on the surface of the membrane. Another type is a cross-flow filters. Here, filtration is done on the basis of pore size, but the pores are not clogged due to tangential flow of the particles. The figures here show different types of filtration units used in downstreaming process. In certain cases, the product formed is intracellular in origin and they are intracellular. In such cases, cell lysis or cell disruption needs to be done to release the product. It could be by mechanical means, chemical means, or enzymatic methods. Cell disruption by mechanical methods. There are various types of methods used in this. In this technique, force is used to lyse the cells without the use of enzyme or chemical. In small scale, it could be done by means of mortar and pestle or blender. In blenders, high speed is used to disrupt the cells. Some other methods used in large-scale units are bead beating. In this, a bead mill is composed of a grinding chamber with beads along with the culture, as shown in the figure. The unit is agitated, leading to disruption of cells by shear forces and collision of beads. Next, sonication. In this method, homogenizers which induce vibrations are immersed into the solution. It is a very successful method in small-scale cultures. Freezing and thawing method. The process is expensive and used only for heat-sensitive proteins and enzymes. In this method, slow freezing is done, which leads to ice formation inside the cells. This is followed by melting. It causes severe damage to the cells and finally cell rupturing. Homogenization method. Here, homogenizers are used to create shear force to disrupt the cells. High pressure homogenization (HPH) is mostly used in cell disruption method. In this method, high pressure forces the cells to pass through a narrow channel, as shown in the figure. This creates a shear force. On discharge from the channel, the cells expand instantly, leading to cell disruption. Next, osmotic shock. It uses the principle of osmosis. Water enters the cells, increase the cell volume, finally leading to bursting of cells. Cell disruption methods by means of chemicals. In this method, chemicals or detergents are utilized for disrupting cells. These chemicals interact with the cell membrane components, causing bond breakage. Certain detergents that are used are SDS, ethyl trimethyl ammonium bromide, Triton X100. These detergents act on membrane phospholipids. Care should be taken that the toxic substance residues are not retained in the products. In many cell disruption processes, combination of mechanical and chemical methods are utilized. In mammalian cell cultures, generally enzymatic cell disruption is not required as these cells lack cell wall. After the extraction and separation of the product, the next step is concentration and purification of these products. It includes processes or techniques like chromatography, dialysis, and distillation. Chromatography. It separates molecules by their chemical or physical differences. Certain chromatographic techniques that are utilized are absorption chromatography, affinity chromatography, ion exchange chromatography, gas chromatography. Dialysis. In this, membrane separation technique is used for removal of low molecular weight solutes and inorganic ions from a solution. The membrane used have molecular weight cutoffs. Distillation. In this process, products that have different volatilities can be separated. Precipitation. It is a downstream process used in product recovery and purification. In this method, precipitation is brought about in the solution by changing certain physical parameters like pH or addition of chemicals, examples certain salts. This leads to destabilizing of the structure of the components in the solution, causing them to form precipitates, as shown in the figure. Example, precipitation of proteins can be brought about by changing the pH or salting out. The final step in downstream processing is crystallization and product polishing. It can be done by lyophilization, precipitation, and by spray drying. With this, we finish downstreaming process. Thank you.